Hello everybody, my name is Dr. Lucas du Plessis. I'm a senior lecturer in the Department of Mechanical and Aeronautical Engineering at the University of Pretoria, and this video is just to discuss the recently written mow217 semester test 2 and specifically question 5. So if we scroll down and have a look at question 5, here you can see figure 2, the test frame with a single Shigley Hauler gearbox. This is the test frame or portion of the test frame. It's this frame over here, and the single Shigley Hauler gearbox is attached to the frame. Okay, and what I'm showing here is a close-up of the guide blocks and mounting pins. So these 4 blocks are the guide blocks, and then these 2 pins are the mounting pins. And if I can go back to figure 2, so there are those pins, you pull them out and you put the Shigley Hauler gearbox in position, and then you push the pins through the holes that are drilled in the Shigley Hauler gearbox, and the pins obviously engage with the opposite guide blocks, and that secures the Shigley Hauler gearbox in position. Okay, so if we go through the question, figure 2 shows a single Shigley Hauler that is connected to the test frame. Figure 3 shows 4 guide blocks that are attached to the test frame with 2 mounting pins. Okay, in order to connect the Shigley Hauler to the test frame, the 2 mounting pins are pulled out of the guide blocks and inserted again after the Shigley Hauler has been positioned between the guide blocks. Now, consider the dimensionless drawing of the guide block, and there's the PDF name, and the instruction is to dimension the views of the guide block shown on OCR Forms 31 as if you have the dimensionless drawing of the guide block in front of you. Okay, so what you see on the screen at the moment is the dimensionless PDF with only the views of the guide block. You can see the front view with section view AA here at the bottom, and the right view with section view BB on this side. And this is the memorandum drawing, my suggestion of how to dimension the drawing. The notes are not necessary to put on the OCR forms, only the dimensions. Okay, so what you see on the screen at the moment is the single Shigley Hauler on the test frame. And if we zoom into the mounting block, you can clearly see that there's an extrusion that interfaces with a slot in the aluminium extrusion, and there are 2 fasteners, cap screws, that hold the mounting block in position, and then these holes for the mounting pin, that needs to line up obviously. So this is the guide block. And as with all the other practicums and tests that I submitted, these holes, this is how I indicate the tapped hole. The drilled portion of the hole is indicated here at the bottom, and the tapped portion is concentric to the drilled portion but is slightly bigger. Okay, so to start, it follows that this hole is an important feature. It's important where it's located relative to this surface and this surface. It's also important where the hole is located relative to this extrusion. Okay, so it follows then that for our datum reference frame, we will specify this surface as datum A. Okay, and we link the two, because it's 2 separate surfaces, we link them with a flatness specification as shown here. The letters CZ after the flatness specification refers to common zone. So in other words, our tolerance zone is a single tolerance zone consisting of two parallel planes, a distance 0,03 apart. Okay, and I've made the tolerance quite tight, 30 micron, and that's because the alignment of the block is determined by those two surfaces. Okay, then datum B, there are different options. What I suggest we do is specify the datum leader line in line with the dimension line of the extrusion. That means that we are referring to the symmetry plane of the extrusion as our datum B. Okay. And then just lastly, also in terms of datums, so I've specified the symmetry plane on this front view as datum C. Okay, so, and I've done that by putting the datum leader line in line with the dimension line. Alright, so that takes care of our datum reference frame. The next step is to specify the orientation and flatness of the datums. Now I've already spoken about the flatness of datum A, but just defining the orientation of datum B relative to datum A. So what I've done here is I've indicated I've put the leader line of the datum block. I've separated it from the dimension line and obviously the datum line. So I'm specifying the perpendicularity of this surface as being 30 micron. Now you can also then specify the perpendicularity of this surface, but it's not really necessary because the width of this datum B is already very much constrained in terms of it being a G6 tolerance. So I mean there's only a 9 micron variation allowed looking at the max and min for this G6 tolerance. Alright, so okay, so that's flatness and orientation of datums A and B. Now the next question on the memorandum is is the RA 1,6 surface texture correctly specified for datums A and B, and this is now indicated over here. Surface texture of 1,6 on that surface and this surface over here. Okay, I've also indicated it over here as well as on that surface. So 4 surfaces that need a good surface finish, and then the next question on the memorandum is the diameter 10 hole correctly dimensioned. Okay, and this is now on section view BB. We've indicated the size of the hole as an H7 tolerance plus 15 0, and these tolerance values is available from the tolerance finder. I have shown it in a previous video. I'm not going to show it again here. Just have a look. The tolerance finder spreadsheet is also available as part of the design literature on ClickUp, and it is available during the test and exam. Alright, now what is important, in line with the dimension line, this dimension box arrow is in line with the dimension line, and we constrain it as positional diameter 0,03 relative to A and B. And you could also add datum C here. That wouldn't be wrong if you did that, but at least datums A and B. Okay, so with that, with the positional tolerance, we need a theoretical exact dimension from datum A, which is indicated over here, as well as from datum B, which is indicated over here as the 30 millimeters and 15. Alright, so that's then taken care of, and then what I've also did was I specified a cylindricity constraint of 15 micron, which corresponds to this 15 of the H7 tolerance. Okay, and then lastly I've also specified a good surface or a tight surface texture of 1,6 micron RA for that diameter 10 hole. Alright, so and then the next question on the memorandum, are the two M6 tapped holes correctly dimensioned? Okay, that's, if I can just scroll down a little bit, that's these two dimensions over here, or the tapped holes over here rather. Okay, so we need the depth of the drilled hole, and that's 20 plus minus 0.5. And what's important here is you dimension it from that surface to the if I can zoom in a little bit, you don't use the tip of the hole, you use the flat portion of the hole. Okay, so that's the depth of the drilled hole. The depth of the tapped hole is measured also from the top surface, obviously to where the tap portion ends, and here you could have a plus minus tolerance or specify it as a minimum tap depth. Okay, and then what I did here is I said tap M6 by 1. Okay, so that the 1,0, that's the pitch length into locations, and I specified it as a positional constraint or positional GD&T, a relatively loose tolerance relative to A, B and C. C is important here because this theoretical exact dimension of 20 millimeters implies that these two holes are symmetrically placed about datum C. So it's 10 millimeters and 10 millimeters. This is how I've indicated it. I think it will be misleading or confusing if you now add a line here and give the two 10 millimeter dimensions. So I think this is more elegant and it is straightforward to understand. Right, and then lastly for the tapped holes, what I also did was, because this tolerance is quite loose, diameter 5 millimeter, I've added the perpendicularity of diameter 1 with respect to datum A being the top surface, or this surface is datum A. So I want the holes to be perpendicular to within a diameter of 1 relative to datum A. Okay, and that is alright. Then I think there's also a question, are the overall dimensions given? This is now the overall length of 60 millimeters, this 30 millimeter dimension, as well as this 30 millimeter dimension over here. That's also needed. We can quickly have a look at the notes, but as I said, the notes don't really form part of the OCR forms. Okay, so we specify the material as mild steel, surface texture RA 3,2 unless otherwise specified, surface finish electroless nickel plating between 20 and 25 micron thick. The dimensions apply after the surface finish process. Break all unspecified sharp edges to 0,3 max by 45 degrees plus minus 5, and all unspecified fillet radii to be R0,4 max. Okay, and that really concludes. Sorry, there's one more overall dimension, and this is this 3mm plus minus 0.2, which is the height of the extrusion. So thank you very much for watching.